Yeah, you want me to just like run through what the rules are? Um, and then maybe we can try a couple like practice problems or something like that. Does that sound cool? Or I can just, oh, we can do a problem. Okay, cool. Yeah, we can totally do that. Get my pen up. So, all right. I'm going to run through the rules with like really basic examples because I think that's easier than going through the generic version of them. So one rule, this rule number one, if you have two variables that are being multiplied together and they're the same letter, so I have like here I have two letter x's and they're being multiplied, then the rule says that you add the exponents. So I would add the 3 and the 2, and then that will give me x to the 5th. Okay, so that's when you have like two of the same variable. Now that is different from if you have a single variable with two exponents on it. So in this example, there's only one letter x, and that letter x has two exponents attached to it. In this scenario, you would do multiplication, 3 times 2, and that answer would be 6. Okay, so those are a little bit different because one of them has a letter and the other, or one of them has two letters that are the same letters, and one of them only has a single letter, but with two exponents on it. And then if it's not a multiplication problem, if it's a dividing problem instead, like this, so division, if multiplication is adding, then the opposite of multiplication, which is division, should be the opposite of adding, which is subtracting. So in this problem, I would do 3 minus 2, and I get x to the first. When you're doing subtracting, it does matter which one you put first or second. And so when you're doing subtracting, it's really important that you do 3 minus 2, the top one, minus the bottom one. If your final answer turns into a negative number, so if you do your subtracting problem and your final answer is like -5, we have a rule about that as well. And so you can never end a problem with negative exponents. And so if you have a negative exponent, the rule is that you take the reciprocal of it. And so in this problem, where x is like a whole number, to take the reciprocal, I would do 1 over x. And then when you take the reciprocal, you can change the exponent from a negative to a positive. So x to the -5th would turn into 1 over x to the 5th. Ooh, you know what? I might not have brought that quiz home. Shoot, I think I just brought home the homework and then the quiz we took this week. Is there any way that you can like type in what it looks like, that problem? And then I can totally do it if you can type it in. So I think, I'm checking my notebook right now. I might only have, oh, you know what? No, I posted all my quizzes online. So, oh cool, yeah, we can totally do that. That was easy to type in. I think I posted all the quizzes online too, though, so I can probably download a version of the quiz if you have more questions on that one. Let me finish up these rules, and then we'll totally do that problem. So the next rule, hold on one second, guys. Sorry. Okay, the next one is kind of an extension of rule 4, and that's just if you have a negative exponent on the bottom, when you take the reciprocal, it would move to the top. So it would become on top of the fraction. So wherever it is right now, just like put it on the other side. So if it's already on top, or if it is a whole number, drop it below a fraction bar, and then if it's already on the bottom of the fraction bar, move it to the top. If you have more than one variable inside of the parentheses, you have to distribute the exponent to all variables and actually all numbers as well. So if there was like also a number 2 in here, it would be 2 to the 3rd as well. You got to do it to like everything. Oh, somebody is texting me on Remind. I'm going to have to text them back later. Are there any other ones? There's little things like anything to the power of 0 turns into 1. Is that all? I think that's it. So those are all the exponent rules, and then it's just a matter of like, can you do them? Can you take a problem and use these rules to figure out what the answer is? All right. Oh my goodness. Okay, so let's do that problem. So it is 16 to the power of 1/2. So on these problems, when you have a number to a fractional exponent, you're going to do a factor tree on the number, and you're hoping in this problem, since my exponent is 1/2 with a 2 on the bottom, you're looking for 2 of a kind in your numbers. So like I would do this, I would change 16 to 4 times 4, which is 4 squared, which is 2 of a kind. And so I would change the 16 into a 4 squared. And then you do still need to have this exponent of 1/2 on the outside. And then we just talked on the previous screen, the 1/2, it's going to times with the exponent of 2. So you're going to do 2 times 1/2. We're not changing the 4 at all. The 4 stays the same. And half of 2 is 1, which is the exponent. And so the final answer for that one would just be 4. If 4 had not have worked, you could have broke it down even more. You could have gone 2, 2, and 2, 2. So that's like 2 to the 4th to the 1/2. And then you would do 4 times 1/2. And 4 times 1, or half of 4 is 2. And then 2 squared is 4. And you would have gotten the same answer. So that's how you do that type of problem. It's a factor tree. All right, go ahead and keep typing in what your questions are. Again, I can do specific questions. I'm pretty sure, access my quizzes. I brought home the quiz we took this week, but if you need to look at an old quiz, we can access those. I do have Miss Weiss's quiz. I think Miss Harvey might have also given that quiz. So we can also look at that. Or you can do like what was just done, where you just type it in and then I can write it down. So this is another thing you can do. Or you can just ask generic questions. All right, so this problem, me personally, I like to think of this problem as almost like 2 separate problems. And so I'm going to divide this right here. And so I have a problem that is the fraction 15 over 45, and that's just a regular normal fraction. And I feel like this is something where a lot of students might overthink it. This is just, I need to simplify this fraction. So I need to think of a number that is divisible evenly into 15 and 45. And that number is 15. And so I would get 1 over 3. And that's for like this side. For this other side, and this was a rule that we talked about on the previous problem, you're going to subtract. And you always have to do the top number minus the bottom number. And so this is just a to the first, or just the letter a. Now, since this exponent is a positive number, that means that this a is going to stay on top of a fraction bar. And if we look at my simplified fraction, there's a 3 on the bottom. So for my final answer, I would write an a on the top, and I would write a 3 on the bottom. And then that is what I would write for my final answer. Compound interest. Yes, we could totally do that. Do you have anyone in particular, or do you care? Can I just like take the one off my quiz? Okay, cool. I have my quiz, I think. That's not my quiz. All right. So compound interest, you have to know a formula. I'm pretty sure we're going to type the formula on your test tomorrow. So don't worry about memorizing the actual formula. The important thing is you have to know how to use the formula. So you have to know like which numbers go where. So again, the formula will be typed on the test for you, but you have to know what numbers to put where. All right. Let me see if I can type out the problem so that we can analyze it together. To move all these wires. There's so many wires, guys. It's ridiculous. Ivy deposited $10,000 into an account paying 5% interest, compounded semi-annually. What will the account balance be after 6 years? All right, so here's the word problem. And so we just need to figure out like which numbers are which letters. And so the $10,000, that's the letter P. P is like how much you're starting with. And then the 5% interest, that's your R, that's your interest rate. And you have to change that to a decimal. So we're actually not going to use the number 5, we're going to use the number 0.05. And you can change it into a decimal if you just divide it by 100 on your calculator. Semi-annually is telling us our N, and semi-annually means twice a year. So that means N is 2. So there's actually a lot of different words you need to know for N. Annually is once a year, semi-annually is twice a year, quarterly is 4 times a year, and then monthly is 12 times a year. So just figure out like which of those, it's going to be one of those 4. I mean, you could do like daily, but I don't think we do daily because 365 is way too big a number to have to calculate with. And then finally we have 6 years, and that's your T, that's your time. So those are all the numbers, and then we're going to plug them in. So it's 10,000, 1 plus 0.05 divided by 2, and then that's to the power of 2 times 6. And then on this problem, you can't just like type this all into your calculator. It's not gonna work out nicely. So what you want to do first, you want to get the inside of the parentheses down to a single number, and you want to get your exponent down to a single number. And so I'm going to keep the 10,000 on the outside. Can't do anything with that yet. And then in my calculator, I would type in 1 plus 0.05 divided by 2. And then my calculator will tell me that that is 1.025. And then 2 times 6 is 12. And then this whole thing, you can totally type that all into your calculator at once. So just type that all in. You can type it in exactly how it looks. So when I'm typing this in my calculator, I do 10,000 parentheses 1.025 close parentheses to the power of 12 equals. And then this is a money problem, so you have to have 2 numbers after the decimal. So the answer is 13,448.89. And make sure when you go to your test tomorrow that you bring a calculator that you've used before, so that you like know where all the buttons are, and so that you know that how to use it correctly. All right, I see we have another problem typed in, so we'll go ahead and try that one. Ooh, that's not a 4. All right, so on this problem, there is a mandatory first step. So anytime that you have an exponent outside of a parentheses, you have to start by distributing that. When you distribute it, you need to give it to every base. So I'll need to give the 2 to the t, n to the m, and to the 3. So I feel like most students forget to give it to the number and we just give it to the variables. So it's going to become 3 squared. And then we talked earlier when you're distributing, you're going to multiply the exponents together. So I'm going to multiply the 4 times the 2, which will give me an 8 here. And then I'm going to multiply the 5 times the 2, which will give me a 10 here. And then anytime that you have a number to a power, you do want to actually figure out what that is. So like we don't want to end the problem with a 3 squared in it. So we definitely want to change that 3 squared into a 9. We did a problem like this earlier, and we said, you know, look at the numbers 9 over 2 and see if you can simplify those. And in this problem, they don't simplify. I can't think of a number that divides evenly into 9 and 2. So I'm just going to leave the 9 on top and the 2 on the bottom. Next, I noticed that the letter M, there's only one of them, so that's just going to kind of stay put. I'm not going to do anything with that. And then finally, I do need to deal with my letter T. So since it's a fraction, we're going to subtract the top number minus the bottom number. And so that's t to the third. And when you get a positive answer, you're going to put it on top of the fraction. And then that would be your final answer. We can't do any more math with that. All right, let's take a look at the next one. So we have f squared, g to the 0, f to the negative 3. So earlier we said anything to the power of 0 turns into the number 1. So this g to the 0 right here, it's going to turn into the number 1. And like you don't have to write that down. When I see something to the power of 0, I normally just like scratch it out. Because it's just not going to be there anymore. It turns into the number 1. It's not going to be the letter G anymore. So we're just going to make that go away. And so now I have my 2 letter F's and the G is gone. And since they're being multiplied together, I'm going to add them. So 2 plus negative 3. And 2 plus negative 3 is negative 1. And then you're not allowed to end a problem with a negative exponent. And so since this is a negative 1, I'm actually going to drop the f down to the bottom of a fraction bar. And it would become x to the positive 1. And since I don't have anything else that I can, I don't have like anything else to write on top, I do have to put something on top. So I'm going to just put a placeholder of 1. So the answer to this problem, honestly, I would write 1 over f as the final answer. All right, Jaden, I see you copy and pasted something from Delta Math. Some of the notation came in a little bit weird, specifically the percentages. Can you retype those percentages in yourself without the copy and paste so that I can see exactly what they say? Because the formatting got really weird. And then we can totally do that problem together. I'll grab my calculator while you retype those in. Jaden, can you type in those percentages for me again? I can't see them. The formatting is weird from the copying and pasting. Okay. 4 and 7/8. And 4 and 5/8. Okay. All right. So first of all, we definitely don't want to leave those fractions. So what I would do on your calculator, um, you can type in, so it was 4 and 7/8. You can type in 4 plus 7 divided by 8, and that should write it as a decimal instead. So 4 plus, excuse me, 7 divided by 8 is 4.875. And then we need to change that from a percentage to a decimal, so we're going to divide by 100. So that is 0.04, I hate that, it does it every time, 4875. And then we're going to do the same thing for the other one. So we'll do 4 plus 5 divided by 8, and then I'm going to divide it by 100. And for that one, I got 0.04625. Okay, so we have to change them from a mixed number into a decimal, and then we have to change the percentage into a decimal. So a couple things to make it a little bit easier to work with. The first one, Paisley, it says it's compounded daily. That's 365 times. And it's going to be a 365 up here as well, because if you remember the formula, and again, if you don't have it memorized, that's okay, because we're going to give it to you on the test. But the formula was A equals P times 1 plus R over N to the power of N times T. So I have to put that 365 up there as well. Kayla's, oh, continuously. Oh, hun, no, don't do continuously. Click give up. Okay, because we're not going to do continuously on your test tomorrow. So find one that does not say continuously and do that one instead. Because it's a completely different formula. It's PE to the RT, and we aren't learning that in this class. So don't worry about the continuously problems. Just click on the give up button until you get one that says something more like daily or annually or semi-annually or something like that. I hope that makes sense. And you definitely do not have to do continuously on the test tomorrow. That will not show up. I know it's on Delta Math. Unfortunately, we couldn't say, hey, don't put any continuously. They're just kind of all mixed up together. All right, and then retype in those fractions for me, hun. Annually, monthly, perfect. This one will work. All right, so he has 590. Okay, so we're going to do the same thing where we convert it. So in my calculator, I wrote 4 plus 1 divided by 4 equals, and that gave me 4.25. And then I'm going to divide that by 100 so I can get a decimal. And so for my first one, I think it said Blake, it's 0.0425. That one is being compounded annually, so my letter N is a 1. And then the next person is also 590. And we're going to convert that fraction. So 3 plus 7 divided by 8 equals, and I got 3.875, and I'm going to divide by 100. And so my actual decimal is 0.03875. That one was compounded monthly, so out of 12. And then it says 14 years. How much more money? Okay, so my time is 14. Oh my goodness, those 4s are just so annoying. 1, 4. Okay, so T on both of them is 14. So here's the setup. Again, the formula is how much money you started with, and then it's 1 plus your interest rate, your percentage, divided by N, which is how often they give you money. Annually is once, and monthly is 12 times a year. And then you also need to put that N in the exponent, and then you need the time. just like on the one we did earlier, I'm going to get the inside of the parentheses down to a single number, and I'm going to get my exponent down to a single number. So 590, and this is 1.0425 to the power of 14. Down here, also this and this. For the parentheses, I'm definitely going to use my calculator. So I typed in my calculator 1 plus 0.03875 divided by 12 equals a ginormous number. And then 12 times 14 is 168. Now these, you can type all into your calculator at the same time. So 590 parentheses, 1.0425 close parentheses, to the power of 14. Since it's money, I'm going to write two numbers after the decimal. 1056.62. Monies. All right, next one, 590 parentheses, 1.003229167, close parentheses, to the power of the very big number 168. Okay, so on that one, I got 1014.09. And then the last thing you have to do, it wants to know how much more money Blake has. So you need to take Blake's number minus Mila's number. Okay, so subtract those. Then it says rounded to the nearest dollar. So when you're all done, don't include the decimal part. Is that 1056.62 minus 1014.09? So I got 42.53. I'm going to guess that 5 is going to round that up to a 43. So I would say that the right answer is going to be 43. I hope that's right. I know that part of Delta Math was really tricky. We definitely will not have those crazy percentage decimal, the percentages with the mixed number fractions, and it's not going to be that intense on tomorrow's test. But I know you have to do that for your Delta Math grade, so. Awesome. Yay, we did it. What else do you guys need help with? So again, I have my textbook, I have some quizzes. You can just literally type in problems, which is what most people have been doing. You can ask a generic question, like I need help with this type of problem. What else do you guys need help with? That's one of the students. They're typing in questions. That's how I know what they need help with. See? Oh, see, there's 4 kids. All right. I'm going to answer his first because I have to download your quiz, Hun. So let me, I will download the quiz while I'm answering his worksheets. All right. A new car was purchased for $18,000, so that's my original amount. The value of the car depreciates. So, you know, on those other ones, we were doing 1 plus, because that meant we were getting more money. But if it's depreciating, it actually is less money. So we're actually going to subtract on this one. So anytime it's getting smaller, like depreciating is getting smaller or decreasing, you want to do subtracting instead of adding. And then we do have to change that percentage into a decimal again. So you can do 13.5 divided by 100, and that would be 0.135. And then what is the value of the car after 14 years? So that's going to be your exponent is 14. Now, just like on our previous problems, I do suggest that you get this down to a single number before you get a final answer. So I'm going to subtract that in my calculator right now. 1 minus 0.135, 0.865 to the power of 14. And then this whole thing, you can just type that all into your calculator. So it's 18,000 times 0.865 to the power of 14. And this one says round it to the nearest cent, so you do want to include your two numbers after the decimal. Now, on our test tomorrow, we will not tell you to round at all because we kind of assume that you know that anytime you're dealing with money, you should always put two numbers after the decimal. So we're not going to tell you to do that. We do expect you to just kind of know, like, oh, I should put two numbers after the decimal. Cancel. All right. Yay. Let's see, number 11. All right. So 4 squared to the 1/2, and then 5x squared to the 3rd. So on this type of problem, you do, because there's those exponents on the outside of the parentheses, you do want to start by distributing those in. So I'm going to distribute in the 1/2, and then this 3, it distributes to the x, but it also distributes to the 5. So you want to make sure you give that to both of them. And when you're distributing your exponents, it's a multiplication problem with the exponent that's already there. So the 4 already had an exponent of 2, and that's going to get multiplied with the 1/2. And then this 5 did not have an exponent, so I'm just going to give it an exponent of 3. But the x did have an exponent, and so I'm going to multiply that with the 3. So if there's already an exponent, multiply them together. And then if there's not, just give it an exponent. For the 4, the 2 times 1/2, half of 2 is just 1. So this is just 4 to the 1st, which is really just the number 4. And then you can figure out 5 to the 3rd in your calculator if you need to. 5 to the 3rd is 125. And then for the x, I have to multiply the 2 and the 3, so that's x to the 6th. Now, when you're all done with the problem, there should only be like one of each letter, and you should have done like as much math as possible with your big numbers. So like I really should keep going with this. I should multiply 125 times 4, and 125 times 4 is 500. And so this would be my final answer. All right, guys, I think I've answered all the questions that you've typed in. So if you've been waiting to type in a question, now would be a great time to do that. It doesn't have to be a specific problem. You can just say, like, I need help with this type of problem. And I have examples. I can find examples. So let me know what you need help with. The same quiz, hun, that we were just looking at? Okay, cool. All right, so this one is 8x to the 1/3, and then 3x to the 0 to the -2. All right. So I said before, like the first thing you should do is distribute your exponents, but I'm gonna change that a little bit. If you see anything that with a power of 0, you should just get rid of it. And so this x is being risen to the power of 0. Now it's just the x, it's not the 3. And so just the x, I'm going to scratch out and pretend like it's not there anymore. And then when I scratch out that x, now this exponent of -2, it only has to go on the number 3. So I don't have anything out here, so I'm just going to leave this in 8 and x to the 1/3, and then the 3 will become a 3 to the power of -2. And then since it has a negative exponent, I need to drop that down below a fraction bar. Now the 3 is the only thing that's going to drop below the fraction bar because it's the only thing that has a negative exponent. So the 8 and the x to the 1/3, they just kind of stay put. And then the 3 goes on the bottom, and when you put it on the bottom, it can become a positive exponent instead now. So 3 squared. And then I should figure out what 3 squared is. And before you decide that this is your final answer, just check really quickly and make sure, like, I can't simplify 8 over 9. And I only have one letter x, and all my exponents are positive, and so we're done. And this would be your final answer. All right, so I hope you started with, we have our initial population, which is 13,000. And if it's growing each year, then you're going to do a plus. And since it says every year, you don't have to do the like over n thing or anything like that. So you can just plus and then change your percentage into a decimal. So that would be 0.045. And it wants to know what's the population after 13 years. So 13 would be your exponent. And then again, I do highly suggest that you add the inside of the parentheses before trying to get a final answer. So in your calculator, you should be typing 13,000 parentheses 1.045 close parentheses to the power of 13. So I got 2303, and then I got 8.5. But the 0.5 will round the 8 up to a 9. And this one, because it's population, so 0, 1. Oh, because so this one is actually oh my goodness. The one is actually a 100 percentage, and then this is 4.5%. So what's happening is we're keeping 100% of our population, and we're adding an extra 4.5%, which gives me 104.5%, but we're not allowed to write it as a percentage, and so that's 1.045. And so anytime you have a percentage problem, you always need a 1 right here, and that represents the current people that are living there, or the current amount of money you have, or whatever it is. It's saying this is 100% of what I currently have, and then I'm going to add an extra 0.045. Or like on the previous problem, it was saying I have 100% of what the car's worth, but each year I'm going to subtract off 13.5%. So this is actually saying like 100% minus the 13.5%. But we can't write it as percentages, so we write it as a decimal instead. And as a decimal, 100% just becomes the number 1. So that's where that 1 came from. And again, anytime you're working with decimals, you have to put a 1 in the parentheses, and you will either add or subtract depending on if it's getting bigger or smaller. If it's not a percentage, if it says like you have bunnies and they double every week, if it just says like doubling, then you can just go straight to 2 to a power. Or if it says tripling, or if it says it's being cut in half, right? So if it's not using an actual percentage, then you can just straight up use the number they gave you. But percentages always have to have a 1. Awesome. Glad we got it right. What other problems do you guys need help with? We have exponents. I think most of it's going to be like the playing with the exponent problems. We will have compound interest. We also will have some graphing problems, growth and decay. You might have to tell me if something is linear or exponential or neither, because it could be not linear and not exponential. So what else do you need help with? Yeah. So there's a couple different types of problems that we can ask you. The easiest one is graph. If we give you a graph, if it makes a straight line, it's linear. And if it makes a curve, it's exponential. Okay? So that one's the easiest. And then the equations are, and then, obviously if it's some other weird graph, it's neither. So these are probably the easiest that we could give you. Linear, exponential, neither. We could give you equations. So a linear equation is something that can be written in y equals mx plus b form, where the x is being multiplied with like a number. And an exponential equation will give you something where the x is in the exponent position. So if either of these two things does not happen, then you would pick neither. I think we had one on a quiz that was like x times y equals 8. So since the x is being multiplied by the y and not by a number, that would be a neither, right? Or you could have something like y equals x squared plus 3, where there's an exponent, but the exponent is not the letter x, it's the number 2. That would be a neither. So for exponential, it really has to be that the x is the exponent, not anything else. And then linear, again, you can write it in slope-intercept form, and that would be linear. And then the last type of problem I think that we can give you is we can give you a table of values. And on the table of values, honestly, you don't really need to check the x's. Usually the x's are just one number apart. They could be anything one number apart. Like it doesn't really matter as long as they're one number apart. Okay, so we're not even going to focus on the x's. Like we don't even care about the x's. What we really care about is the y's. So for the y's on a linear, you should be increasing by the same amount each time. So like on this one, I added 3, I added 3, and I added 3. You could also be subtracting. Subtracting would also work, but it has to be like adding or subtracting. So that's how you can figure out that it's linear. And then for exponential, it has to be timesing by the same thing each time. So for instance, on this one, I'm timesing by 2. I'm timesing by 2. And I'm timesing by 2. So if you can get from one y to the next by always multiplying by the same number, that's exponential. And then on neither, like it's just, a bunch of random numbers where there's no pattern. You can't find an adding pattern and you can't find a multiplying pattern, then that would be neither. I think those are the only ones we can ask. Let me just make sure I don't have anything else on one of these worksheets. Yeah, I think those are the 3 different types that we can show you. No, and I'm in the middle of class. No, you may not. Okay, what else? We have about 10 more minutes left if you have more questions. No, you can read a book. Yeah. If there aren't any more questions, I'd be okay with logging off early also. So don't feel like you have to stick around if you don't have any questions. I'm more than happy to answer your questions. I'm just not seeing anybody typing any in. So if there's anything else that you need help with, it can be generic. The last one was a very generic question. Or it could be a specific problem that you type in, or maybe you have a quiz question. Um, I'll wait a little bit longer, but if nobody types anything in, I'm cool with signing off early also. So you guys let me know. We have 10 minutes left. All right, guys. If there are no more questions, I'm going to go ahead and sign off. I wish you the best of luck on your test tomorrow. Um, yeah, good luck.